JK is somewhat understated. It's an early JK Rubicon, got some aluminum bumpers on it, not much else on the outside. This JK has a full Genright Elite chassis, 4-link with Dana 70s, King coilover shocks. We actually replaced the chassis. We did not modify the original chassis with an Elite chassis. We've got an Atlas 2-speed transfer case, 3-to-1. We have a Gen 5 L86 direct injected engine and a 6-speed transmission. That's right, this one's running a 6L80, not an 8L90. 6L80 is still a great transmission in a Gen 5 motor. It is running a full GM CAN network, cruise control, Tapshift. We are using a factory GM harness. It has a PSC XD steering gear. It is set up for a hydraulic ram. The Gen 5 engines are becoming more readily available. The L83 now can be had new, and you have your choice of a 6-speed or an 8-speed transmission. They both work great. I guess my advice would be if you get large tires like 40s, the 8-speed might have a slight advantage because you have a 4.6 low first gear rather than the 4-to-1, and you have a slightly taller 0.6 versus a 0.66 overdrive. I think one of the unmentioned heroes of the LS swap is not so much the engine, and we talk a lot about the engine, it's the transmission. One of the problems with the V6 3.8 is it's burdened by the 4-speed transmission, the 42RLE that Chrysler's been using for quite a while. It's an old-fashioned valve-body transmission. The gear spacing is not very good. You got a 2.8 first gear. You don't have a very tall overdrive. It's high friction, high heat. That's why you guys got to run the giant transmission coolers, and it really bogs down the power that the 3.8 has available to it. If the 3.8 had a better transmission, like an 8-speed transmission, I think it would have been a much more viable engine in the JK. The Pentastar obviously has got the W8580, which is a much better transmission. However, in my opinion, neither transmission can stand up to the 6L80. The 8L90 is an interesting transmission. It does have more diverse gearing and a larger gear spread. The 6L80 is an amazing transmission because it's a software-driven transmission, and it has the transmission control module built inside of it. What that means is we've reduced the wire count going into the transmission many-fold. We have CAN wires going in and out, power, ground, brake, just a few simple wires, no more Prindle, IMS, solenoids, and all the other wires that are required to operate a traditional transmission. So the 6L80 is very simple to set up in a vehicle, and it's all controlled over the CAN. On the Gen 4 and the Gen 5 engines, it's not like the earlier Gen 3s and earlier engines where you have a powertrain control module. A powertrain control module, or a PCM, controls both the engine and the transmission. An engine control module only controls the engine. And on the Gen 4 and the Gen 5 engines, they only use an ECM. The transmission is controlled by a TCM. So the 6L80 has the TCM built into it. The 8L90 has an external TCM. Just like the early days of the Gen 4, when they used the 4-speed 4L65s, 4L70s, they used an external TCM called the T43. And the T43 literally was a transmission control module that was standalone, and it interfaced between the ECM and the transmission. By putting that TCM inside of the valve body, we have eliminated all the wires that go between the TCM and the transmission when it's externally mounted. So the 8L90 has gone back to that external TCM design. One of the biggest issues we have, and I'm going to try to address it, but it's very complex, is cooling. And it's not just with the LS, it can be with the Hemis, it can be with the LTs, it can be with superchargers, and even stock Pentastar JKs we've seen overheating. Basically, in order to cool the engine in your vehicle, you have to pull air through the radiator, which lowers the water temperature or coolant temperature, and that cools your engine. So there's two critical parts there. One is water flowing, and two is cooling that water, or coolant. I'm calling coolant water. You can put a giant radiator in your JK, but if there's no airflow going over the core, it's not going to cool. So many years ago, we developed our 52mm dual pass radiator, which we have determined is the best combination or compromise of core size versus airflow. You can go with a 5-row radiator, and we have, but you're blocking the airflow at that point, because remember, the JK has a small engine compartment. So what you're trying to do is pull low pressure air into a high pressure zone. So you want as little restriction as possible, but still maintain the capacity of the radiator. So we've determined that our 52mm dual pass and the fin count that we're using does that. And our radiator will cool a V8 and a JK, even here in Las Vegas. But we got to get airflow to it, so that's the next step. If you're going to go off-road, you're probably going to have a winch, you're probably going to have steel bumpers, you're probably going to have lights. If you install all those things in front of your grill, that's not going to make the airflow happy. Something you have to realize is, even if you just have a stinger 2 feet out in front of your grill, the air that stinger deflects can move the majority of the airflow away from the grill and over the hood, so you're not getting cooling air into the grill. We install more powerful cooling fans like the Pentastar and the Camaro SS fan, which are capable of pulling a lot of air. Obviously, GM has spent a lot of time on these LT engines. I heard they spent millions of hours on the head design. Because face it, basically an internal combustion engine, it comes down to the heads for the efficiency. The rest of the motor is an air pump. Yes, they have more low friction components inside, roller bearings, or we're running 0-820 oil. So there's efficiencies in the lower end too, but the cylinder heads is really where it's at. Going to direct injection means we can run higher compression and a more efficient combustion chamber for complete combustion. Also, we can keep emissions lower. By having control of the camshaft, being able to phase the camshaft anywhere at any time also can reduce emissions but still increase performance. Bottom line is, these LT engines are going to be capable of power levels beyond anything that came before it because we have better control. We can control the cylinder pressure more accurately. And with the direct injection, while fuel volatility is important, it's not as important as the early engines where we could not control cylinder pressure as accurately. So these engines are going to be the future. The LTs are here, and if you want to do an engine swap in your JK or your JL, I would start looking at the LT. Gen 4 engines are still very viable. Don't overlook those if you have an earlier JK, 7, 8, 9, 10, 11. Gen 4 engines make a great choice. I'm running a 2009 L9H in my own JK, and I have no intention of swapping it out. But if you have a new JK, 15, 16, 17, JL, you're going to want to start looking at the LT engine. In my opinion, GM did have some bugs in the LTs, just like they had in the LSs. First and foremost is AFM. Airfield management works by disabling the lifters to turn that cylinder and air spring, and it's pretty complex. Now, it's very reliable. AFM has been out for a long, long time. However, in an engine like this, it puts out tremendous horsepower, tremendous torque. It can be very stressful on the internal components. So airfield management has been an issue in the early LT engines, just like it was in the early Gen 4 engines, and just like some other manufacturers. My point is these LT engines have now gone through the majority of their teething cycle, and now they're going to make good, solid engines. 17, pretty much most of the issues with the LTs is gone. And a lot of my customers with the earlier LTs don't have any problems. However, the engine's just going to get better and better. GM is going to continue to improve them and get more power and more economy out of them. I do believe when GM launched the LT engines, it was their intention all along to be conservative up front and then open these engines up down the road. I think what we're going to see in the next couple of years, GM's going to open these engines up, and we're going to see power and economy numbers that the Gen 4 engines can't match. The Gen 5 motors have a tremendous amount of torque. This can be an advantage if you have a heavy JK or a JK with, let's say, 40-inch tires. What you have to consider about large tires is, you got 40s on your JK, they can weigh 200 pounds with a rim. That's 800 pounds of wheels and tires you got to turn, and you have to stop when you brake. That can put a lot of strain on the drivetrain. Having so much torque so far down in the power band means that you can turn these 40s with ease. Now I'm running 37s right now in this Jeep, and it's driving like it has 32s because the torque of this Gen 5 engine. Would an LS3 run awesome in this Jeep? Yes, it would. Is an LS3 simpler? Yes, it is. It has fewer parts, and in my opinion, it's a more reliable engine. If you were going to run through the desert at King of the Hammers, the LS3 is the way to go. However, the LS3 cannot offer you the advantages that this engine has. This engine has the ability of better economy, has more bottom end torque. It's pretty incredible if you Google and look at the LT torque curve, how flat it is, how low it comes in the power band. There's really not much else out there like it. You see these 480, 500 horse engines peaking at 475 foot-pounds of torque up at 4,000 RPM, but it's like a pyramid, it's like a triangle, where these LTs are pretty much flat as a dinner plate right across, and it's a usable torque that gives you the ability to turn these heavy tires and pull a heavy JK. So the other advantage is fuel, of course. These LT engines don't require as high of an octane fuel as the Gen 4 engines. GM eliminated the power steering pumps on most of the LT engines. They're running electric assist on most of the new vehicles. They have lower friction accessories, like the alternator has a one-way bearing in it to reduce friction for better economy. And bit by bit, GM is going to make these LTs as efficient as they can. But let's give them some credit, and let's give Dodge and Ford credit too. They are getting horsepower numbers that we never dreamed of in the past, and they're doing it while staying US EPA legal and giving us efficiency that we didn't have in the past. Tapshift ability here. Let me bring it back and shift. So we're supporting full tap shift in both the 6-speed and the 8-speed, as well as the current gear indicator in the dash. So getting back to the LT engines, they're the engine of the future. They're the engines that you're going to want to have in your JK, JL, or whatever, starting from about now on. I think the technology in the aftermarket is finally at a point where we can launch these LT Gen 5s mainstream. Get them out of beta. GM has done a lot of learning, we've done a lot of learning, and we're finally realizing the advantages of these LT engines. The torque of these Gen 5s is really where it's at. The bottom end torque allows us to move these heavy JKs more efficiently. And it's always been that way, by adding displacement, adding a supercharger, whatever. So if you get an LT in your JK, let's say you're running 513s with 37s in your JK now with a V6. Then you get a Gen 4 engine. You're going to want to drop that down to about 456s. That'll keep you about 2,000 RPM at 70. That's the best balance of economy and performance we found. Now you put an LT in. You can drop it down to 410s with 37s. By running those 410s, you're bringing your RPM down on the highway. Having the tremendous torque of these Gen 5s off the line means you don't have to worry about launching your JK. You're running lower RPMs pretty much everywhere you go for efficiency. You're also able to run the lower grade fuel, so that can save you a little bit of money. Now let's talk about a legal standpoint. We've been doing a lot of swaps on the 15s, 16s, 17s. And now we're going to be doing a swap on a JL. Y'all know the rules. You have to have an engine that's essentially the same year newer than the chassis. And the Gen 5 is just going to be the engine that you're going to have to go with if you want to stay with GM.